Hello, dear students. Welcome to this workshop on two experiments, charging and discharging of the capacitor and LCR circuit. Before I begin, I would like to thank Professor Dr. Rama, Principal, Hansraj College, Delhi University. Professor Chetna Jain, Teacher in Charge. Program coordinators, Dr. Rangoli Bhatnagar, Hansraj College. Ms. Chanchal Yadav, Hansraj College. Convener, Dr. Yogesh Kumar, Hansraj College. And Secretary, IAPT. I am thankful to them for their kind words, which they have spoken about me. And this workshop is on training workshop on innovative hands-on experiments with Arduino and its application at your college, that is Hansraj College, Delhi University. First of all, I will take you to my website, which is www.harisejwani.com, to show you how you can learn most of the things about the Arduino, and then I will come back on to the main topic. So this is my website, www.harisejwani.com. My name is Hari Sejwani, and you will see that you come to my site. This is my site. This is home, course, about, contact, 11 physics, 12 physics, innovative experiments, and IAPT RC1 events. I am a member of the Executive Council of IAPT RC1. And this first of all, you are at home, and you can register yourself on my website. Login perhaps is not, I have not activated. You can upload your file, whatever file you want to upload. You can mail. I can mail all the registered persons, but I will not do that. I'm more interested in telling you about the innovative experiments that I have made in physics. As soon as you click on this, you will have large number of the lectures, say 11, 12, 13, 14, 15, 16. 16 lectures I have put on my website. And once you feel any difficulty in Arduino, then you can see one by one. First of all, most important lecture will be the lecture number 1, in which I have explained the various parts of the Arduino, and then you can see other things from this. But I am now closing it because I wanted to show you that if you want to learn something about the Arduino, there are 16 experiments based on the physics by using the Arduino. And Delhi University has introduced 2 experiments which have to be done by Arduino. Otherwise, they can be done very easily in the lab. But using Arduino, it is a trick which you will understand today. So I'm just closing down on this website, and then I'm coming again to this. Now, it is said by Einstein, when you stop learning, you stop living, and that is the fact. You should continue to learn something new, whatever is as per your time. You can and continue to learn new things, latest technology. You must be aware of what is going on. Then I'm trying to explain I want to explain what is Arduino, what can it do. In fact, Arduino is an open source electronic platform for engineers and non-engineers. This is very important. For engineers and non-engineers. It is not necessary that you have to be engineer for learning Arduino. In fact, a student from the class 7 to class to higher classes can learn. And it is also not necessary that only the science students can learn Arduino. The science, arts, commerce, everyone can can learn. It is so easy to operate on the operate using the Arduino that anyone from child to mature person can learn the Arduino. Arduino can read inputs such as the light or light on a sensor, button status, detect the motion and turn it into the output voltage, rotate a motor, read various resistances of the LDR. LDR is a light dependent resistance. Is a device which is a sensor device which if the light is allowed to fall, then the resistance of the light of the LDR will change. Can be used to read the potential from the potentiometer, measure the distances of the object with the help of the ultrasonics. It can measure the temperature, it can measure the humidity. Imagination, in fact, is the limit to the application of this. The components which will be used in the Arduino are described here. Arduino board, we need Arduino board, breadboard, use cable to connect the Arduino board to the laptop or the computer, various sensors, LEDs, resistances, capacitances, multimeters, speakers, and the batteries, etc. These are the components which are required, not necessarily all at a time, but whenever you need, you may use any of these. But Arduino board, breadboard, and the cables to connect the Arduino board are most important thing. The software which will be is used for running the Arduino programs is freely available on the Arduino.cc. Now I will explain various parts which are important components which are used in the Arduino. First of all, you can see the Arduinos have been given to you. So you can see your Arduino, and then whatever I am explaining, try to understand. There are two parts of this Arduino. One is the upper part, and another is the lower part. You can see, and you can see that there are pins. These are the holes. These are the holes in which certain jumpers will be used to connect. So these are the pins: 0 pin, 1, 2, 3, 4, 5, 6, 7, 8, up to 13, and then there is a ground, then the reference voltage. You can see here is the RX. This is 0 pin is an RX pin, and 1 pin is a TX pin. RX pin is a receiver pin whenever communication is to be done through some wireless device, then some signal has to be received, and that will be received at the pin 0. And then if you want to transmit certain signals, then it can be transmitted from the TX pin. However, these pins 0 through 13, all these pins are called as the digital pins. You can see from here, these are the digital pins. These are the digital pins. Digital means 0 and 1. Whenever we talk of these digital, then it means either 0 or 1, high or low, yes or no, true or false. All these are the digital, which have only one value, either 0 value or the 1 value. So whenever you want to have the digital values, then you can go from this point 0 to any of these pins can be used. Also, you see that there are some special symbols, tilde symbol, which is on your laptop at below the function keys on the left hand side. You can see this symbol. symbol. These are the PWM pins. PWM means pulse width modulation pins. Yeah. If you want to have not 0 and 1, but somewhere between 0 and 1, say 1.1, 1.2 floating values, then you can use only these pins, pin number 3, 5, 6, 9, 10, 11. These 6 pins can be used as the PWM pins, in which the fractional value to which where fractional value can be given. If nothing is said and we say that this pin is high or this pin is high or any of these pins is high, then it gets some high voltage. That high voltage is basically fundamentally it is called as a 5 volt. So whenever we say that this is high, automatically it gets the 5 volt. Whenever we say that it is low, then it automatically becomes grounded, that is 0 value. So it can have 0 and 1. By saying that it is high, this is low. So whenever you are using a particular device with the help of the Arduino, then one end of that device will be connected to the ground, and other end will be connected to any of these pins. And once we say that this pin is high, that means from ground to this pin the current will flow, and the voltage will be available there. Now come to this chip. This is 3286P pin, which is of course a removable pin. Nowadays, of course, this type of the Arduino is very costly because of the chip shortages. However, the SMD type of the SMD means and the chip which is fixed on the surface mounted chips are there. This is a removable chip on which we shall be downloading the program. This is in fact a microcontroller. This is a microcontroller which will be able to do any particular work assigned to it through certain program. It will do only that work. At one time, it can do only one work, but it can do different works by using the different program. However, at any one time, you can use only one program on this Okay. Now these are we come to these pins. These pins A0 to A5. That is, these are the 6 pin 1, 2, 3, 4, 5, 6. These are the pins which are called as the analog pins. Analog means any value between say fractional values, say 2.1, 3.2, 3.4. These are in fact the pins with the help of which you read certain things. You read certain voltages. Basically, Arduino is a voltage control device. All its sensors give you some voltage, and that voltage it reads. Okay. Then this is a V in that I will explain to you. If you want some external voltage to be given to the Arduino, then positive of that will be connected to this pin which is called as a V in pin. Along with this are the two ground pins here and one ground pin you can see here. There are 3 ground pins in the whole of this Arduino. So, and then there is a 5 volt, and then there's this 3.3 volt. In some devices, say microbit, which works at the 3.3 volt, but most of the devices in Arduino will be using the 5 volt voltage. Okay. Now, this is where the USB, using the USB port, we can connect it to the laptop, and once the program has been loaded into this can be it need not be connected to the laptop, and you can give some power from here with the some other device which can be from 5 volt to 9 volt. Okay. Then next thing. This is a breadboard. Another important component. Using this, we can test large number of the electronic circuits, and the beauty of this is that from this point to this point, these are the horizontal lines. These are two horizontal lines at the top, two horizontal lines at the bottom. All the points on a given horizontal lines are connected to each other. However, there are certain breadboards in which from this point to this point, all the points will be connected to each other. But there are certain breadboards in which there are two blocks. One block is this, another block is this. In this block, on the pins from this point to this point are connected to each other. Pins from this point to this point are connected to each other. Similarly, pins from this point to this point are connected to each other. Pins from this point to this point are connected to each other. If you want that all the pins from this point to this point should be connected, then you should connect this point with this point, or this point with this point, as I have shown below. Here also, from this point to this point, all pins are connected. From this point to this point, all the pins are connected, but this line is not connected with this line. Similarly, there are vertical lines. These are the vertical lines. All the pins on the vertical lines are connected to each other. They are connected to each other, but the pins of the one vertical lines are not connected to the another vertical line. Okay, so using this, we shall be making certain circuits, test circuits, and then this is a cable to connect this. This point is connected to to this particular point. So and then the another USB point will be connected to the computer. Okay. And then I have shown some sensors on this. Which I will just show you. This is of course our Arduino. There are various sensors. This is the IR sensor, in which there are two LED type of the devices. One is the transmitting, another is the receiving one. This is a temperature, humidity sensor. This is a LDR sensor. This is a the Bluetooth sensor. Large number of the sensors are available with us. This is a ultrasonic sensor, with the help of which we do so many things. Yeah, and then there are LEDs. LEDs are there. The LED strip is there. Then this is a transmitter. LED is there. Yeah. Then this is again I would like to explain. These are the variable resistances. Small rheostat. This is a large rheostat. This is of course both type of. Normally in our electronic circuit, we should be using small rheostat. However, whatever is what you want to use the higher sensor, then you can always use it. In all the rheostat, there are 3 pins. One pin is this, another pin is this, third pin is this. One pin, second pin, third pin. Of course, the extreme pins, this pin and this pin, are given some voltage. So positive of the positive of some battery will be connected to this point and negative to this point, or positive to this point and negative to this point, depending upon how do you want to connect the circuit. And then the central one is a central pin, which will be giving you with respect to this one or with respect to this one, will be giving you the different variables by rotating this. Similarly, positive of the battery is connected to this, negative of the battery is connected to this, or vice versa, positive to this and negative to this, and this is connected to some variable terminal, which will give you some voltage. This point will give you some voltage with respect to this or with respect to this, depending upon how do you want to measure. That depends on. Then this is a resistance color coding you have already studied in your lower classes. This is a half watt resistance. The symbol of the resistance is like this as well as this. So in some circuits you will find out that resistance is shown like this. In some circuits you will show that the resistance is shown by this. However, it is a matter of only showing the Then there are capacitor. You will be using the capacitor in your 2 electronic circuits, which you will be studying today. This is a electrolytic type of the capacitor, having a capacity is equal to 4,700 microfarad. various values capacitors are available, which are say 100 microfarad, 1 microfarad, 2 microfarad, 0.01 microfarad, 100,000 microfarad, with various capacitors are available to us. And in the electrolytic capacitor, there is always a negative. Negative is written here. Normally, two pins, one of the pins will be shorter, another pin will be longer. But if you cut like this, then you will not be able to find out which one is negative, which one is positive. But in the here, this since negative is written, so this end will be negative and this end will be positive. One precaution has to be taken that in the electrolytic capacitor, you cannot connect the negative to the positive and positive to the negative. If you do that, then the whole of the capacitor will be damaged. And since positive cannot be connected to negative and negative cannot be connected to the positive, therefore you cannot apply AC, because in AC one end will become positive and other end negative, and after half cycle the one in the end which was positive will become negative, and this will damage the Then there are two other type of the capacitor which are non-electrolytic capacitors, capacitor which will be required in our experiment LCR circuit experiment. This will be required in our charging and discharging capacitor study, and this will be required in LCR study, where ceramic capacitor, various type of the ceramic capacitors are available, and they are having the various values also. These are also the similar thing. Then in order to make the circuits, we have to have the three jumper wires. These jumper wires are three types of the jumper wires are there. One is the female, in which at the end there are pins here, there are holes here, there are holes here. Then another is a male, in which there are certain pins coming out here. Then there are male, female. On this side, there is a pins are coming out. This is a male side, and these holes are there, which is a female side. Then there are servo motors, sleepers, and stepper motors, etc., etc. All these are the sensors. Now, Arduino ID, I told you that Arduino programs can be run with the help of an integrated development environment. This software, corresponding software, is available free of cost on your browser, on your browser. Simply go to the browser and type what you want to type is arduino.cc, www.arduino.cc. It is not necessary to type www. Simply write down arduino.cc and press enter. You will be going to the Arduino CC. Then we shall be using that Arduino IDE will be explained with the help of the to experiment. But first of all, we will be studying the charging theory of the capacitor, and then we shall be going in for the discharging. See, theory of the charging, qualitative. Of course, quantitative theory you have already studied in your theory, but today we shall be studying only the qualitative nature of the theory of the charging. So here are two plates A and B of the capacitor. One plate is connected to the positive of the battery through the resistance R, and a second and the other plate of this is connected through the negative through the key to this plate B. So if you connect it, then what will happen is this positive will take the electron out of this. This plate initially is neutral. This is a simple copper plate or aluminum plate or any conducting plate. This is neutral one. So if you these conductors, the good conductors are those which have large number of the electrons which are free to move randomly within the conductor. So this plate, although is a neutral one has large number of the free electrons, and the positive ions which are rigidly bound within the metal conductor. The electrons are freely moving, And once the force, this attractive force, positive, this positive will be attracting the electron. So electron will be attracted toward this. So electron will be moving like this, and the current will be moving like this. Conventional current is always in a direction which is opposite to the direction of the motion of the negative charge. Negative charge. And what happens to the plate B? As the electrons are coming from here and attracted by this, and this becomes, since this is the electrons are leaving it, therefore negative charge is leaving it, therefore it becomes positive. As more and more of the electrons will be leaving it, this will become more and more positive. But what happens here? This is a negative. Negative means having excess of the electron. This negative of the battery has excess of the electron, and these electrons are repelled. Once the circuit is completed, these are repelled by the negative, and then the electrons go from here and go to the plate B. So plate B becomes negative. But you can see that as more and more charge, more and more electrons go to this becomes more and more negative. And you know that negative repels the negative, and therefore whatever as this is becoming more and more negative, it will repel the electrons. It will resist the motion of the electron towards this. So there are two forces acting on the electrons going from this negative to the plate B, and those two forces are the pushing force by the negative of the battery. This pushes towards the plate, and unless this is completely charged, this will be opposing the motion of this. So it will be trying to push it in this direction, whereas this is trying to push the electron in this direction, and therefore successive charges will be able to move slowly and slowly, slower and slower. Yeah? As the charge goes on increasing on this, the charging becomes slower and slower, and therefore you will be getting some particular type of the on this I have already explained, particular type of the curve, and that curve is initially the charging is faster. Charging is faster because and as more and more charge is available on the plate B, then the repulsive force goes on increasing. A stage may can come when it is so much charge that the motion of the electrons towards the plate B will go on decreasing. And when it is completely charged, fully charged, then no more electrons will be able to move from the negative to the plate B, and no more electron will be coming from the plate A towards the positive. So this is called as the saturated voltage. So initially it is faster, and then it becomes slow and slower. You will be seeing, of course, experimentally with the help of this Arduino that this is actually happening. You can see that once you are able to measure the charge with and plot a graph with the between the T and Q, you will be able to find out the RC. That is the time constant. However, you know that the capacitor is equal to Q divided by V. C is equal to Q divided by V. Therefore, V will be equal to Q by C. Once we have taken a given capacitor, so C becomes constant. So V will be proportional to the Q. Since it is very difficult to measure the value of the Q and very easy to measure the value of the voltage, therefore, instead of measuring the charge, we measure the voltage, which is directly proportional to the charge. As the charge will go on increasing, voltage will go on increasing. Therefore, instead of plotting the graph between the time and Q, we plot a graph between the time and the V. This maximum, we can always note down what is the maximum voltage. And at 0.707 of the maximum, if you draw a line parallel to the time axis, and you draw from, it will cut this curve at this particular point, then you can draw a vertical line on this, so that this point will give you the time constant at which the voltage falls to 1/√2 of the maximum voltage. 1 over under 2 means 0.70, okay. So this gives you time constant. So by plotting this graph, you will be able to measure the value of the time constant, and that is the purpose of this experiment. Now, what about the discharging? Discharging, oh, theory of the discharging, the qualitative. So once the capacitor has been charged completely, this has maximum negative charge, this has maximum positive charge, and we have the one end of the resistance connected to this ground, and we also connect the B to the ground. But since both are connected to the ground, this circuit is equivalent to this circuit. So A plate, B plate, this is negatively charged, and this is through the resistance it is positive. Now, since this is a short circuiting, so this has large number of the electrons. This has small number of the electrons. That is, it is having the deficiency of the electron. This is having the excess of the electron. So electrons will be moving from this to the plate B. Plate B. And therefore, this will start discharging. Initially, since this is fully charged, it will apply maximum force on the electron. So those electrons will be moving very fast and will be going to the point A. As this goes on discharging, that is, the number of the electrons on this goes on decreasing. What happens is the successive repulsive force goes on decreasing, and therefore the charging also becomes smaller and smaller. So initially the discharging becomes smaller and smaller. So initially this discharging is very fast, and later on the discharging becomes very small. When only few electrons are left, they will be applying very little force on this, and it will take very large time to completely discharge this capacitor. So, however, the discharging will also depend upon the value of the R, the resistance. If resistance is very small, then this will be almost instant, very easily it will be discharged. But if the resistance is large, then the discharging will be very slow. So the curve for this will be, and I have already told you that we shall, instead of measuring the charge, we shall be measuring the voltage. So since V is proportional to Q, therefore potential difference V across the capacitor decreases. Graph between the T and V is shown like this. So initially the voltage is maximum, then it falls rapidly, then this discharging becomes slower and slower and slower. Ultimately, it is completely discharged at infinite time. But of course, we stop much before this. And 1 over under 2 of this maximum value will give you the time constant, and by discharging and charging for both, you can find out the value of the RC, then the time constant, and you will find out that the value comes out to be same in both the cases. You can repeat this experiment by taking the different values of the R, different values of the C. So you can take large number of the sets of the reading, and after plotting this graph, now I will show you the actual performance of this. First of all, see the circuit. What we have done in this circuit. Of course, I am not using the voltmeter because my program will automatically give me the voltage across it. So I have a capacitor, electrolytic capacitor. That electrolytic capacitor is one end is this, and another end is this. This end is positive end, and this end is negative end. Negative end is connected to negative. This line, all the vertical line is there. Say this, since this is a vertical line and all the points on this are connected to each other, therefore this point is connected to this line. Which line? With the help of the Arduino board, this is ground. This ground is coming from this point to this point, and we connect it to this point. So whole of this line becomes the negative. So this end of the capacitor is connected to the negative, another end of the capacitor is connected to the resistance, because all these points are connected. So once you are going to here, you connect a pin here, then it will be connected to this. Then it is a 10K resistance. This is a brown, black, and the orange. So this is a 10K resistance, and then this point is connected to the 11 point. I told you that these are the digital pins. If I make this pin number 11 as high, then what will happen? This end will have 5 volt and this end will have the 0 volt. So the capacitor will start charging. But if I make this pin number 11 as low, then this is ground. Then this becomes a ground, and this is also a ground. So since both are ground, so therefore there is a short circuiting through this resistance, and hence the discharging will start. So this is a simple basic principle of charging and the discharging. So first of all, we will make this point as high to charge this capacitor. Then we will make this point as low to discharge this capacitor through this. One end is already grounded. So since one end is grounded, so when this is high, 5 volt, and through the ground it comes this discharges, and when this is low, then it charges. Initially it charges, and then when this is low and this is already low, so there is a discharging of the capacitor will take place, and this will be automatically done by the help of the program. Now, once you have understood the circuit, then I take you to the actual program, which will be with the help of which we shall be performing the experiment. Program is loading, and I will explain to you the program. Taking too much time. Yes. Okay. So here, this is a program which I have already made, and I will make you understand. And you have to simply write this program as you want to write. First of all, it is important to note that in any Arduino program, there are two important functions called as the setup function and the loop function. These are very, very important. You have to have these two functions which are defined by word setup, and whenever any function is defined, then in the we have to make a block, and within that block we write down certain instructions. So you can see that this is the block, this is a curly bracket, and this is a curly bracket. So within this curly bracket there are certain instructions written here. So setup function is a essential function. If you remove this setup function, it will not work. This Arduino will not work. After this, you can see there is another function which is called as a void function. This is loop function. This loop function is also having the block which is defined by the curly brackets. Within this curly bracket, whatever you write down, that will be executed. In the loop, in the setup function, whatever instructions are given, that will be used only once. In setup function, whatever instructions are given, that will be executed only once. But in the loop, whatever instructions are given, first of all, first instruction will be executed, then second instruction will be executed, and then again it will be first instruction, again second instruction, and so on and so forth. So these are the two things. However, there are certain variables which have to be defined. Since we want, there are, say, in our capacitor, in this you can see that this junction I call as the resistance junction, resistance end. Okay, this point where this is positive is there, then it is connected to the pin number 9. We have to read certain things. Here. So there is a R and C junction. This is a C, and then this is a R. So this point is an RC junction. This is resistance and this is the resistance pin. You can call this as the resistance pin, and you can call this as the RC pin. But it is up to you to give any name you want, and whatever your name you want to give, you may give. So what I have done is RC junction pin. We are to read certain voltage as it is charging as well as discharging. It will be reading certain voltage at that particular point. And for reading, we connect it to the analog pins. So analog A1 pin I have chosen for this. So then resistance pin has to be this pin has to be either 5 volt or 0 volt, 5 volt or 0 volt. Alternately, we shall be making it as a high voltage and low voltage for charging as well as the discharging. Then we are using another pin number 9 called the LED pin. Although it is not necessary for this experiment, but this LED pin will show you that as the charging is going on, the voltage is going on increasing, and therefore the intensity of the LED pin, if we see that value in the LED pin with the help of the LED pin, then what we shall find out is that the voltage is increasing, therefore the LED will glow more and more and more. And as it is discharging, then the brightness of the LED will go on decreasing. Ultimately, it will become 0 when it is completely discharged. It is not necessary for you to use the LED pin, because you will be able to see the value on the monitor, on the serial monitor. You will be able to see the values. Okay, and you can record those values. Then we have shown here as a LED pin is 9. Then we shall be measuring certain values with the help of our this analog pin, and those values has to be 4.1, 4.2, 2.1, 1.1, 0.01, 0.02, etc. These type of the values are called as the float values. And if there are only digit, then these are called as the integer. 9 is integer, A1, this is integer, this is also integer. Okay, so the integer, I have given resistance equal to 10,000. Capacitor, I have chosen 1,000 microfarad. 1,000 microfarad, I have written like 1,000 point. Because if we are to use the float value, then it has not, we cannot write down 1,000. We have to write down 1,000 point. Or you may write down 1,000.0 or 1,000 point is more than sufficient, into 10 raised to power minus 6. 10, then this type of symbol is the symbol of the power. Then bracket may I have minus 6. So that means it is 10 raised to power minus 6. That is the micro. So 1,000 microfarad we are using. And then we are given taking the TC. TC is the time constant. Time constant is multiple of the R and C. Then we are defining for taking the successive value, we need certain time. Okay, one value, then another value, then another value. If the time, if that happens very fast, then we shall not be able to record the values. So we are taking some del value 5,000. it will be delayed. Every successive operation will be delayed by 5,000 milliseconds. Then in the setup, what we are doing, since we are using the LED, since we are choosing the resistance, and since we are choosing the capacitance also, therefore we are defining three things. We have to give pin mode. LED will give you the light, and therefore it is called as a output mode. So LED pin, which is which one? Which is pin number 9. Okay. So once we are writing down LED pin, and we have already defined as pin number 9, so it will say pin mode LED pin means pin number 9 as the output. Pin mode resistance pin. Resistance pin has to be either has to have 5 volt or 0 volt. So I call this resistance pin as the output pin because it will have 5 volt as a output and 0 volt as the output. Okay. Then RC junction. At the RC junction, we are reading something. So we will be inputting certain things, and then we will be based upon that reading, we shall be making certain outputs. Okay. So RC junction pin. It is not necessary that you name this pin at the RC junction pin. You may give any name, but this is logical. Logical names will be always better. So RC junction pin will give you the input, and then if you want to see the values on the monitor, the desktop monitor, then there is a internal command, that is a serial dot begin 9600. This is a baud value, the number of the bits which will be processed per second. Number of the bits per second, processing speed is there. So there can be larger other speeds also. Large number of these speeds will be available with us. Yeah. And then there is a digital write. Digital write. Initially in a setup, first of all, what we want to do is that if the capacitor is already discharged, I have already charged, then it should get discharged. If it is to get discharged, then we write on digital write, digital read, analog write, etc. These are few very simple commands which you can always understand. You can name is itself digital write. It will be writing down on the RC junction low. Digital write RC junction pin this is a mistake. Okay. It should be R resistance pin. It should be resistance pin. It should be resistance pin. I am so changing here. This is resistance. This is resistance pin here. Resistance pin low. Okay, that's why it was making certain mistakes. Okay, so digital write resistance pin low. So I am making the resistance pin as low initially, only once. For sufficient time, this time I shall reduce to 10, 15,000 milliseconds. So I'm saying then the delay for 15,000 seconds, 15,000 milliseconds. That means for 15 seconds. So once this resistance pin is low, that means the pin which is connected at the pin number 11 will become low. Then the other end of the capacitor is already grounded. Therefore, it will start discharging. And for 15 seconds, it will continue to discharge. And if some charge is already available on the capacitor, then that charge should ultimately become equal to 0, nearly 0, not necessarily 0. But that will depend upon how much time do you give it to discharge itself. Then there is a void loop. I'm calling it as a charging, then discharging, then charging, then discharging. But charging has, when I've written charging, there are two small brackets, opening small bracket and closing small bracket. This is a function. I am defining a function below, one function for the charging and another function for the discharging. So you come here for how I have written the charging function. For writing down any function, we are defining the charging function. We have to write down void, first of all void, and then charging bracket start bracket close. For any function, I told you that we have to have a block. So you can see I have a block here. This is a block from here to this one. So that block is there. Within that block, whatever instructions we write down, that gives you the charging and the discharging charging function. I am writing down serial dot print line, print ln. This you cannot change. It has to be like this. It is a internal function, and in which I am writing down within the quotation mark charging starts. And if I write down only print, then charging starts will be printed, but anything else which we want to print will be printed on the same line. But when we apply ln, then it will charging starts will write down on the same page, on same line, and the other things will be printed on the other lines. Then we are writing down the digital write resistance pin high. While charging, we are making the resistance pin high. So we are giving to the resistance the 5 volt, and the other end of through the resistance there is a capacitor, and the other end of the capacitor is connected to the ground. And therefore what happens is the charging will start. And now there another concept. Analog pins, you know, I don't know whether you or not, they are 10-bit operation. They do the 10-bit operation, and the digital pin they do the 8-bit operation in this particular device. Of course, there may be certain device in which the analog pin may be using the say 12-bit or 16-bit or 32-bit. In the digital, it may be 8-pin functions, or the 8-bit operation or 10-bit operation or 12-bit operation, whatever it is. But in our Arduino, they are having the analog pins are having the 10-bit operation, and 2 raised to the power 10 gives you the value is equal to 1024. That is the basic concept. Now you should understand. Any voltage which is given is divided into 1024 parts, because it is a 100. So 0 corresponds to 0. The highest 1024 corresponds to the 5 volt. Any value in between will lie between the 0 to 5 volt. We will be reading this value, and so suppose it comes out to is 512. So 512 is half of the 1024. So 512 will correspond to 2.5 volts. So in all the sensors gives the value between the 0 and 1024. If you understand this principle, then you will be able to do anything that you want to you want to do. So since the maximum value will be 1024, therefore I am asking it while value is less than 1024. Instead of writing down 1024, I have written 1018. Y18, it has been done by me through the experimentation. If I give it 1020, then of course it is almost at almost reaching the 1024. And when the capacitor becomes almost fully charged, then the charging will continue up to infinity till it is fully charged. So therefore, we shall not be able to attain that value, and we will have to wait for infinite amount of the time to get this 5 volts. So instead of that, we will stop by charging it up to say 4.9 volt or 4.92, 4.95, etc., etc. So for 1018 gives me up to 4.96 value. So it's perfectly okay for me. I am charging it from not from the zero value, but from, I'll show you later on. So well, it's less than, while well is less than. Where is well? Well is a digital read. Say well is equal to analog read, initial value of the well we have defined above, and that well was equal to 0. Now well is equal to analog read. Analog read where what to read? RC junction, where R and C are joined. There the capacitor is having certain voltage. That voltage has to be read. So analog read RC junction pin. So whatever voltage is available there, it will be read and it will be assigned to the well. It will be somewhere between the 0 and 1023, because 0 to 1023 becomes 1024. So we are reading this value, and in order to use our LED, we are mapping this value to the well 1, another variable which we are calling as the float value. Map well between 0 and 1023 to the LED, which is connected to the digital and to the PWM pins between 0 to 255. So when the value of the well is 0, the value of the well 1 will also be equal to 0. But when the value of the well 1 is 1023, then the value of the output will be LED will be also will be 255. This we can convert into our voltages instead of now. So what we are doing is analog write whatever val 1 we have got, we have converted into the digital pins, and then we are writing that value to the LED pin. So LED pin will have the voltage which is obtained by mapping this value. So if this value was 0, then that value will be 0. If that value was 100, the value will be 100 multiplied by something. So we are converting it into our measurable voltages. Well multiplied by 5 divided by 1024. I told you that 5 volt is divided into 1024 parts. So therefore, the well is being divided by 1024. And this is serial dot print, serial dot print, serial dot print, serial dot print, serial dot print. All these things which are written with the print will be printed in the same line. So in the first line, first of all, it will be printed the capacitor voltage. Then it will give you the value of that capacitor voltage. I have given some space here, so after some space it will be printed. Then we have written within the quotation mark, I have written the volts. Then I have written the LED volt, etc. And how do I know the LED volt? Well 1 is the value which was given to the LED. So well 1 multiplied by 5 divided by 255, because the digital pins are have the 8-bit operation. So 8-bit operation means 2 raised to power 8, which is equal to 256. From 0 to 255, it is 256. Then comes this. So you can see that while this is less, So as this is value, this is charging, as the capacitor is charging, what is happening is the reading that which is coming to the well goes on increasing. It goes on increasing, and then once delay, we are giving the delay of 5 seconds. We have defined del is equal to 5,000. So delay is a function which will delay the next operation up to del time, del milliseconds. So 5,000 milliseconds means 5 seconds. Then once this value exceeds 1018, so long as value is less than 1018, it will continue to charge. But once it becomes more than 1018, it will come out of it, and then we ask it to return. Return where? I called that function charging function. From this charging function, it comes to this function which we have defined, and then it becomes returns. Then we define the discharging function. For discharging function, say serial dot pin we are discharging star, digital write resistance pin as low. Resistance pin as low. Resistance pin low becomes the ground. And the capacitor one pin is also already ground, therefore it becomes short circuit. And since it becomes short circuit, therefore its value will go on decreasing. So long as while val is greater than 10, I could easily write down while val is greater than 0, but it will never approach the 0 because charging will never finish to 0. Some charging will always remain on the capacitor. Therefore, if we write down 0, then we will have to wait for infinite amount of the time for getting the 0 value. So I have written is so long as while val is larger than 10. Initially, when it charged, its value was nearly 1000, 1018 or 19, etc. something. Yeah. Now it has got the value. If while is greater than 0, greater than 10, then val is analog read again. It will be reading this value. Next reading it will read when it has discharged something. Next reading it will take when it has discharged something. So value of the val will go on decreasing. So while this is happening, we will print out etc. these voltages etc. And once that condition is satisfied, that when it falls below the 10, then it will return to where we are calling it as discharge. So first of all, it will be charge, then discharge, then charge, then discharge. Now this is a program which has to be loaded on the chip of the Arduino. Now for that, what you have to do is first of all you have to connect your Arduino to the laptop. And you can check the program without even connecting the laptop to the laptop. Arduino to the laptop. But it is desirable that you connect your Arduino to the laptop and check the program. If you are checking this, compiling the sketch, it is, and then it said the done compiling. It says done compiling, okay, but it's simultaneously it is showing that it is not connected. Why it is saying though? Let me see. So we go to the tools. We go to the tools and we see that Arduino, we have to choose two things. One is the board, which board you are using, and at which port you are taking for uploading the program. This is of course Arduino Uno. Arduino Uno we have taken. And if there is any other board, then you can go to this point. And there are so many other boards which are written there. But since we have already chosen, now here is a port. There are 3 ports it is showing. It is showing you the 3 ports, COM 13, COM 14, COM 15. These are ports, but we have to choose this pin, say COM 13 pin. Okay. Any one pin can be chosen, but then if there are more than one pin being shown, normally it will show which pin is connected to the Arduino, but it is not showing at this moment. Sometimes it will show, sometimes it will not. But once it is not showing, then you take the pin, choose the pin, and it is showing now COM13. But suppose it does not work with the COM13, then you will choose each of COM14, then again choose COM15 if it does not work. With whatever, now we have to upload the program. Upload the program on this. So whatever is written here already. So I will be uploading the program. I am uploading the program. Compiling done, then uploading, and then uploading. Oh, what happened? That is the problem. So I close the program and reload the program. And again check the port. Port is COM13 now. Actually, port is Arduino Uno, board is COM13. Now, once this has been, and then what about the board? About board is Arduino Uno. It's okay. Now, what I do is I just load the program on this. You will see the compiling the sketch and then uploading. Done uploading. So it is very important that your Arduino is connected to the proper board and the proper COM. Now I can show you that this program has started working, because I have already connected certain component, which I will show you. So I instead of for showing you, I stop the sharing, and you can now see that this is the board, and on this board I can show you this resistance. I have taken a very small Arduino board. This is a breadboard. I have taken this resistance, and this is one end of the resistance, which is connected to the negative. Negative of this is this one. This one point is connected to this point, this line, and from this line I am taking the negative point. So this negative is connected to the one end of this, and then the another end of the resistance is connected to the negative of the LED, and the next end is connected to the point number 9, as I have already shown you. Now, then this is the capacitor. This end is negative. You can see that negative is written here. This is negative is written here, and this negative I have given from this negative line. I have given this point to this negative. Then the positive point is connected to the resistance 10K, and this becomes the what? This becomes the RC junction. This is R, this is C. So this point becomes the RC junction. This becomes the RC junction, and from this RC junction, this resistance is there. This resistance pin is there. Pin is connected to the pin number 11. So actually what you can do is, it is not necessary for you, and again taking out this pin, taking out this pin, taking out this one, taking out this one, and taking out this one. I want to show you, since you will be doing this experiment in your lab, it is not necessary for you to make the connections first.
you can download the program on your again I am sharing the screen. Once I share the screen, you can again see that here is a program, and I have connected my Arduino. I have connected my Arduino, this Arduino, to the laptop. Once I have connected to the laptop, no connection has been made on this board. Although no connection has been made on this board, this toolkit shows that our Arduino is connected to the Arduino board, and this is connected to the pin number 15, which is Arduino Uno pin. Okay. And then for the sake of showing, I am again loading the program on this. See the program compiling done, uploading, and then uploading done uploading. So you can see that no component is there on this. So therefore, it is desirable that whenever you want to do any experiment with the help of the Arduino, first of all, check the program, load the program, and then make the connections. So I will show you the connections now. I will make the connection before you. So I stop sharing and then I make the connection. See, here is a ground point for me. Here is a ground. This is a ground, and I'm connecting this ground black wire to the ground pin. Ground pin, connecting to the ground pin, and the RC junction. This is a resistance junction. Resistance junction is connected to the 11. Resistance junction is connected to the pin number 11. This is 8, 9, 10, and 11. Pin number 11. And RC junction. RC junction is connected to the A1. A1. RC junction is connected to the A1. And the capacitor pin. Oh, this one is connected to the A9. To the, sorry, 9 pin number 9. This is pin number 8. This is pin number 9. This is connected to the pin number 9. And then has been done. Yes, final connection has been done. And you can see that the program is running. And I can show you again what is happening on the yes. It is showing that it is charging. And I have got a paper. On this paper, I can go on writing down the values. Since every reading is taking 5 seconds, therefore initial reading was 0.06 at 5 seconds, then 1.88, And then I can write down 3.91 and then 4.20, etc., etc. We will go on noting down these values. We will go on noting down these values and then record those values in the. So let the charging start again, and then I will start reading, noting down the reading. Discharging is starting. Initial value is at 0 second 4.9494, at 5 second 3.12, at 10 second 2.04, and at next second 15 second is 1.38, then 0.0.66, and then 0.42, then 0.126, then 0.1616. 5 second is more than sufficient. 4.166, and then this value is coming out to be wrong, 0.13. Then comes the this wrong 0.06, and then 0.04. Then the charging at 0.0 second, the value is 0.04. At 5 second, the value is 1.88, and next value is 2.96. Next value is 3.98. Then next value is 3.97. Next value is 4.59, and then 4.75, then 4.88, and then 4.94, and then it is 4.85, then 4.92, and then 5.00 volt, 5.00 volt. Somehow it has come, and then again the discharging starts. Discharging 4.98, second set, 4.98, 3.17, 2.03, 1.03, then 0.64, then 0.24 is discharging. Oh, this was charging, okay. 0.44 is wrong. This is wrong. 0.09, 0.09, 0.05, 0.03, and then again the charging starts. Charging starts at 0.04, 1.89, 3.27, 3.65, 4.28, 4.53, 4.69, 4.78, 4.85, 4.87, then 4.90, 4.76 is a wrong, 4.94, 4.96, and then the discharging starts. So once we have taken the data, we can put the values of this data in our Excel sheet and plot the graph there. Plot the graph there, and now thank you very much.